Yeah, this is from 2013. Ted had sent this one to me, and I'm going to try to do as many problems as I can, but I'm getting ready to leave town this weekend, so I'm not going to be able to do as many as I want to do. But anyway, let's take a look at this one, number 8. You're given an arithmetic sequence which involves logs, and we're trying to solve for x. If the sum of the first 20 terms is equal to 100, so we need that sum formula, which is the sum of an arithmetic is n over 2, and then 2 times the first term, u sub 1 plus n minus 1 times d. Well, let's see what we know at this point. We know the sum. The sum is equal to 100. The number of terms, we know that's 20. We know the first term is 1 over log of x base 2, and I'm not going to put that in yet. And n is 20 again, so that's going to be 19 times the common difference. So I need to find that common difference, and I'll go back and fill in that first term in just a second after I show you how to rewrite this. Well, this series looks kind of weird, and in order to find the common difference, that's the main problem. So I need to rewrite this somehow. And you may notice that all those bases are powers of 2. So if there were some way to rewrite this so that we could see what the common difference is, then we'll have it ready to go. So what I'm going to do is notice that log of x base 2 is the same as 1 over the log of x over the log of 2. That's the change of base formula. And 1 over any fraction is just the reciprocal, so that's the log of 2 over log of x. So let's go through and write every term in a similar fashion. Log of x over log of 8 over log of x would be the next one. And then the log of 32 over the log of x, etc. And the last one given the log of 128 over the log of x. Well, it's still kind of hard to see what the common difference is. So what I'm going to do is take each of those logs and rewrite them. And this is dot, 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 of course. As the first one is 1 log 2 over log x. The next term, 8 is 2 cubed. And remember the power property. You can pull that power down. So we've got 3 log 2 over log x. And in the next one, 32 is 2 to the 5th, so that's 5 log 2. I bet you can see where this is headed now. And then the next term is 128, which is 2 to the 7th log 2 over log x. So when we write it like this, we can see what that common difference is. Because each time you're adding 2 log 2 over log x. That's the common difference if you subtract. So now we can go back to our formula and fill in 100 equals 10. That's 20 divided by 2. 2 times the first term, and I'm going to rewrite that as log 2 over log x, plus 19, which was n minus 1, times the common difference, which we discovered to be 2 log 2 over log x. Now it's going to get a little easier, so let me get some of this stuff out of the way. I'm going to take this rewrite and see if I can slide it down here without messing things up too much. Okay, let me scroll down a little bit. There we go. Now we're ready to go. So, object, find x. Well, we got a formula there, and the only variable is x, so let's see if we can clean this up. Let's divide both sides by 10. So we get 10. And what we have inside the parentheses is 2 log 2 over log x plus 19 log 2 over log x. And that looks like 21 log 2 over log x. Okay. At this point, well, time out. It's not 21 log 2 over log x, I just realized. Because we have 2 log 2. 19 2 log 2's. So that's 20 2 log 2's. Or if you want to think of it as this, that 2 log 2 is the same as log 4. So we have 1 log 4, 19 log 4's, we've got 20 log 4's. So at this point I'll just leave it as 20 2 log 2's. Let me draw that fraction bar a little bit longer so you can see that. So we got 10 and we got 20, so we'll change that to 1/2 by dividing both sides by 20. And I'm going to rewrite, I guess I'll just go ahead and no, let me leave it as 2 log 2 over log x. That's going to be fine. Because what I'll do is divide both sides by 2, so I get 1/4 equals log 2 over log x. And let's see, what do I want to do now? How about, I think I'll just reciprocate both sides. So 4 equals log x over log 2. Multiply both sides by log 2, so I get 4 log 2 equals log x. And then 4 log 2 is the same as log of 16. Almost out of room, but almost done. So I got log 16 equals log x, therefore x equals 16. And that's what we were trying to find. So it got a little messy in there, but nonetheless, turns out just the way we wanted it to. X equals 16 is the correct answer. Done on this one, Ted. Thanks.